with me. Today I'd like to look at this website called Zooniverse. I suppose that's how you pronounce this. This is a website for citizen scientists. So here different research groups can post their research and ask for help from citizen scientists like you and me. So I did something similar once with, I guess, X Hunters or something like that it was called, where we helped scientists hunt for, I don't know, was it the Higgs boson? Anyway, so here I want to have a look at the projects that are on this website, and then maybe do one or two or even more, I don't know, and maybe in the future I'll revisit this and do some more, I don't know, but for now I just wanna get an overview. So you can see we're on the projects page here, and down here you can see the projects ordered by discipline. So for example there is space, and I already selected space, so you can see all the projects related to space down here. So for example there's the burst chaser, and if you hover on it you can see a bit more information, but not that much. So unveiling the mysterious origin of gamma ray bursts. Then there's the Einstein at Home pulsar seekers. Join the search for pulsars. Help Einstein at Home scientists to identify these amazing cosmic lighthouses. Then there's the Gravity Wave Zoo. Identify atmospheric gravity wave events that take place over the Arctic region. This one sounds quite, I don't know, intriguing, because I have no idea what gravity waves are. Then there's the kilonova seekers. Find cosmic explosions in real time with the gravitational wave optical transient observer. New data uploaded hourly. Then there's the cool neighbors. Searching for brown dwarfs, cool neighbors of our sun. Then the super luminous supernovae. Can you find the brightest supernova in the universe? Blobs and blurs. Extreme galaxies in clusters. Help us search for extreme types of galaxies in the Virgo galaxy cluster. The redshift wrangler. Help us use the light from distant galaxies to look back in time to the early universe. The daily minor planet. Discover new asteroids every day. This sounds also kind of interesting. Gaio Verai, or whatever they pronounce that. Uncover the secrets of the universe from the ESA Gaia mission. Witch hunters help us improve our gravitational wave detectors and unlock the secrets of the universe. Black hole hunters, making the invisible visible. Yeah, that sounds like Ghostbusters, doesn't it? Planet hunters NGTS discover hidden worlds with the Next Generation Transit Survey. Dark energy explorers identify distant galaxies to help measure dark energy when the universe was just 2 to 3 billion years old. Citizen ASASSN classify the light curves of variable stars and help us find the most unusual ones. Disk detective. Spot the disks around nearby stars where planets form and well. Yeah, this is probably also interesting. Then there's a second page. Aurora Zoo. How does nature create such a beautiful show? Okay, this doesn't really give away what it's about. Planet 4. Help explore the surface and weather of Mars' South Polar region. Star Notes help us transcribe the groundbreaking work of early Harvard astronomers. Also an interesting one, because it seems to be something different. Galaxy Zoo Mobile help us find galaxies with rings to solve the mystery of how they form. Planet Hunters Test join the search for undiscovered worlds. Super WASP variable stars help us discover the weirdest variable stars. Galaxy Zoo. Few have witnessed what you're about to see. Yeah, okay, that's a bit clickbaity, isn't it? Astronomy Rewind. Help us create a database of astro-referenced old astronomy images. Backyard World Planet 9. Search the realm beyond Neptune for new brown dwarfs and planets. Gravity Spy. Help LIGO scientists make gravitational wave discoveries by identifying how to improve our detectors. Well, now you can even help improve LIGO. Radio Meteor Zoo. Help us identify meteors in radio data. Interesting. I'd say we go back to page 1 and maybe start with one at the top. How about that gravity waves too? Because I want to know what gravity waves are. So, identify atmospheric gravity wave events that take place over the Arctic region. Learn more. What is the aim of this project? There are 3 main science aims for gravity waves to identify gravity waves, instabilities and braking. Learn what conditions are needed for these different events to take place. Compile observations over multiple years to study seasonal variations in gravity across the surface of the water, causing friction between the air and water surface. The winds transport their energy and cause the water to move in a circular motion in the direction of the wind. Okay, well, what about gravity? For a gravity wave to start, something must trigger the air to be displaced vertically. An example of trigger mechanisms is mountains and updrafts from thunderstorms. To generate the wave, the air must be forced to rise up into stable air. Why must the air be stable? If the air is unstable, it will continue to rise and won't be able to form a wave pattern. When air rises into stable air, the stability of the environment will allow gravity to naturally pull the air back down over time. The momentum of the air keeps it moving forward, but the air continues to overshoot its equilibrium point. The parcel of air will try to remain at a location in the atmosphere where no forces are causing it to rise or sink. This results in a propagating oscillation which we perceive as a gravity wave. Okay, so if I get this right, if the air rises, for example, at the side of a mountain, and on top of the mountain it encounters what is called stable air, then over time it will be pulled down again by gravity and then rise again and be pulled down again because it overshoots. So okay, so it's kind of oscillating for a bit, I guess, before it reaches some kind of equilibrium point or something. Not sure I got that right, but well, you can see it here on the image that it's kind of, it goes up, it encounters kind of a barrier, and then gravity pulls it down again, but then it rises again, and then it goes down again, and this is going to be the wave, I guess. Well, to be honest, I was kind of expecting something more spectacular behind the words gravity wave, but maybe let's still see if we can help with the research. So where can maybe I need to go back now. Okay, so we can see here that there are already 765 volunteers, and they have done over 20,000 classifications, and the research part on Zooniverse is 68% complete. So let's have a closer look at how one could help out here. Okay, welcome to Gravity Wave Zoo. In the Gravity Wave Zoo, we ask you to identify gravity waves, instabilities, and aurora in short video clips. The pictures were taken using a camera that views in the infrared, equipped with a fisheye lens so they show the detail in a large part of the sky. Classifying these events will help us understand how energy is transported through the atmosphere. Anyone can do Gravity Wave Zoo, and there is not always a right answer. If you're not sure, just take your best guess. instabilities follow the same light-dark pattern the gravity waves have. Instabilities can also appear without gravity waves present. In this case, the instabilities will appear perpendicular to the direction the wind is moving. So I guess on this image the wind is either moving from west to east or east to west, and the instabilities are perpendicular to that. You can see them here, very small. Lastly, we'll ask if aurora is present. The aurora can be very obvious or slightly more subtle. At times, auroras can appear as bright arcs across the sky, and other times appear as faint pulsating lights. Okay, bright arcs across the sky or pulsating lights. If you want to see some examples, a good idea when you start, press need some help at the task. Okay. Here are a few examples of gravity waves, instabilities, and auroras. So in this picture we have gravity waves. I guess that's the one we've seen before. Here we have gravity waves. Oh, okay, I wouldn't have recognized that probably. And here we have instabilities. And here we have a lot of instabilities and gravity waves and even aurora. If you find something cool or unusual, press done and talk when you get to the end of the questions to let us know about it in the talk. We haven't seen these pictures before, and gravity wave events continue to surprise and amaze us, so you might find something entirely new. Thanks for all your help and time. Let's go. So I guess we have our first task here, and the task is, are there any gravity waves present in the video? So let's run the video. Okay, I mostly see noise, but I guess there might be something just right from the center. It appears and it disappears again. I would say these are gravity waves. Continue. Are there instabilities present in the video? Let's have another look. I'm not sure. I mean, what I identified as gravity waves might also have been instabilities, right? Let's have another look. Okay, look. Need some help with this task. Yeah, they could have been instabilities. Okay, let's try to decide whether they are gravity waves or instabilities. Okay, I would now go maybe with instabilities. So go back. No, there aren't any gravity waves present, but there are instabilities present. Is there aurora present? Well, I haven't seen any arc or pulsating light, so probably not. Okay, so our second task. Again, are there any gravity waves present? Let's have a look at the video. Oh, I'm pretty sure I've seen instabilities, many of them. But I can't really see any gravity waves, can you? But I guess I can see auroras. instabilities? Yes, there are auroras. Okay, next one. I want to see a gravity wave now. Okay, this one is hard, but there are instabilities. What about gravity waves? Not, yeah, maybe up here. Are these gravity waves? Maybe up there are gravity waves. Maybe these are, this is hard. But there are, yeah, let's say there are, or let's look at the examples again. Okay, so stripes of dark, bright, I'm not sure. Okay, let's say no gravity waves. Yes, instabilities, no auroras. Next. Okay, let's look at the video first. This time I don't see instabilities. And I can see auroras. And I still can't really make out any gravity waves. What do you think? Are there gravity waves and I'm just missing them? And I'm just misclassifying all these videos? And they would have looked at it and found very interesting stuff, but because I said no, there aren't any gravity waves, they just dismissed them. Yeah, but I would still say there's nothing in here. No gravity waves, no instabilities, no auroras. Okay, next one. I don't see instabilities. I don't see gravity waves. Or do I? Wait, let's. Okay. Gravity waves usually flow parallel to each other. Okay. Do we have an example video here with gravity waves and auroras? Okay, this video has gravity waves and auroras. Okay, so I guess these are the gravity waves, right? Yes, you can see them here, they move with the wind. Oh yeah, that makes sense, they move with the wind. Okay, let's look again here. No, but I can't see anything. Yeah, let's just say no gravity waves, no instabilities, no auroras, although I'm not exactly sure about the auroras. Oh, here I can almost already see some waves. Let's look at the video. Okay, what is this? This is, I mean, it seems to me that there are waves, but then they are being covered by this bright, whatever layer is coming on top of the waves. And I wanted to see the waves move, but they are just hidden now behind this bright layer of I don't know what. So do we see gravity waves here? Yeah, probably. Do we see instabilities? No. Do we see auroras? I have no idea. What's that bright layer? Let's maybe say waves. Maybe there are waves, but I don't know, they dissolve or whatever, they go away. I'm not sure. I don't think, wait, maybe down on in the bottom left quadrant. No, no waves. Okay, let's say no waves. No instabilities. No auroras. It's pretty, I don't know, boring what we are seeing here. Either that or I'm missing all the waves, who knows. So why is this video not loading? Can I run it? Oh yes, I can. Do we have waves? I think we have. I'm not sure. I'm seeing things. I'm not sure they are there. No, these aren't waves, are they? I mean, they're forming and then they are dissolving. Is this how waves are supposed to work? I thought they have to move with the wind, but maybe they are waves. It's really hard to tell. No, I say they are just random patterns that shortly look like waves but aren't really waves. Okay, what do we have here? This almost looks like waves already. Yeah, I mean it's the same, it's dissolving. It's not really moving with the wind. And no instability. Wait, we have instabilities here. Or are these artifacts? That's really hard to tell now. These artifacts are everywhere around the center, as if they were some kind of artifacts from the Fish Islands or something. Do we count these as instabilities? I'm not sure. Yeah, let's count them, but no waves, right? No auroras either. Let's do another one. Oh, I'm pretty sure I can see instabilities. And maybe even waves. Yeah, this is hard to tell again, but no, these aren't way down here. Yeah, I say we have waves and we have instabilities. It's really just a guessing game. And no auroras. Wow, this one is dark and fast. And I'm really starting to think there's something with these fish islands that's causing distortions that look like instabilities. guess that's auroras. And do we have waves? Not really, it's more like a mesh or something, but not waves. Do we have instabilities? Or is it the lens again? Yeah, the lens. The lens is smearing things out over here. So let's say no waves, no instabilities, but yes, we have auroras, or at least one. Oh, look at these waves. I mean, I haven't even started the video, but I'm betting there are going to be waves in here. Let's look. Yeah, there are waves. And there are instabilities. Or, and even, have you seen that? Even an aurora on the left half side. A very bright aurora. Okay, we have waves, we have an aurora, and we have those lens artifacts that I'm not going to count as instabilities anymore. Or we have instabilities and we don't have waves. Okay, the examples show. I mean, how exactly can they distinguish between instabilities and waves? They look the same. So the waves are supposed to flow with the wind, right? And I think they do that here. So we have waves. And we don't have instabilities. And we have a big aurora. let's say it's instabilities, even though they seem to be moving with the wind, but they are so small. Well, let's say no, let's say yes, and let's hope that a real scientist will have another look at this. Oh, here we have instabilities, right? Well, it went away again. But it was there for a moment, and I'm going to count that. Next. I don't see any waves. I don't see any instabilities. And I don't see any auroras. Let's have a look at this one. Yeah, this is just chaos, right? No waves, no instabilities. And of course no auroras. Oh, here we already have a bit of a wavy pattern. But it would be instabilities because it moves perpendicular to the wind. And we don't have any wave, right? Wait, we have a white point somewhere. Something was moving. Something was moving across the sky. Ah, there, have you seen it? Let's have another look. There it is. I think we can lower the speed. Let's lower the speed. Oh, there it is. Can you see it? I think we found a UFO. No, probably not. It's probably just a lens flare or something. But it looks really cool. Well, I think I need to sign up because then I could click on and talk and tell them about the UFO we just found. But now I can't. Okay, let's look for waves. I don't see any waves and I don't see any instabilities. And no auroras. Except if you count the UFO aurora. Next. Oh, what is this? No. Two little stripes to be a wave. I guess no wave, no instabilities. Oh, this one looks kind of interesting. This one might have instabilities up there. Yeah, there is definitely something, and it's going perpendicular to the wind. So these are definitely instabilities, but I can't see any waves. But let's look again. No waves, but instabilities. Yes. And do we have aurora? Yes, I guess. I mean, look at all that flickering. So let's maybe stop